This video is to help you with section 3.1.1. How can I simplify it? And grouping expressions. So it reminds you that in previous lessons, you've worked with expressions, combinations of numbers, variables, and operation symbols that involve either adding integers or multiplying integers. And today we're going to evaluate and examine expressions that involve both operations, multiplying and adding. So first of all, they talked to you on 3.1 about Katrina writing the following set of instructions for Cecil. They're using the raised dot for multiplication, so 4 times 2.5, 4 times 2 5/10 plus 1. So the question is, if Cecil the acrobat follows instructions, how far will he go? Okay, so they want you to think about what this would end up looking like if you were going to draw a diagram. You had 4 times 2 5/10 plus 1. Then Katrina drew this diagram. How was she thinking about the moves? All right, so we know from the stop and go light there's a mistake in how she's thinking about this. So what type of expression would actually work for this diagram? All right, and hopefully what you should be seeing is it would be that she's thinking of the 2.5 plus 1 as being in parentheses, and then you've got 4 sets of 2.5 plus 1, 2.5 plus 1, and so on. Okay. So when they're asking you to write an expression, that's what they're looking at, that it would be 4 times the quantity, in parentheses, 2.5 plus 1. And then why this diagram, again, would not have worked for the original set of instructions, you're going to explain for C. And then for D, if Cecil changed the instructions so that the 1 came first, how would we think about writing that expression? And does that give you the same results as if you'd written it this way? For 3.2, Cecil's trainers proposed each of these movements. Which one requires the longest rope? Draw diagrams to justify your answer. So for A, you're going to take your 2 times 6 48/100 of a foot and then add 8 to it. So you can start with your 8, but then you've got 2 sets of 6 48/100. As opposed to B, where you're starting with 2 feet and then you have 8 sets, of 6 48/100. And then in C, you're taking your 8 plus 2, which of course would be 10, and multiplying that by 6 48/100. So here you've got 2 sets of 6 48/100 plus 8. You've got 8 sets of 6 48/100 plus 2. Here you've got a total of 10 sets of 6 48/100. So they want you to think about how to diagram that and which one would be the longest amount of rope. For 3.3, if you were looking at this expression, 5 plus 3 times 4 plus 2, they're telling you you could represent it with these integer tiles shown. So here's your 5. Here's your 3 sets of 4, because there's a set of 4 positives, a set of 4 positives, another set of 4 positives. And lastly, here's your 2 being added at the end. Okay, so then how many tiles are there total? And then they remind you that each group of positive tiles excuse me, could be represented by a different part of the expression, which is called a numerical term. A numerical term means single numbers or product of numbers. Okay, and they remind you that it's often useful to circle terms in an expression to keep track of separate calculations. So if you had this, 5 plus 3 times 4 plus 2, 5 would be its own individual term, 3 times 4 is a term, and 2 is a term. Because again, numerical terms are single numbers like the 5 and the 2, or a product of numbers like 3 times 4. Product, remember, means when you multiply. Okay, so now if you had this longer expression, which I rewrote also up here, you have to think about where would the terms be. So 4 times 5 would be a term because, again, it's a product. 1 would be a term because it's a single value. 3 times negative 2 would be a term. All right. And then 6 would be a term. And then if you try to think about what that equaled, all right, you take your 4 times 5, add 1, plus 6, or pardon me, negative 6, because 3 times negative 2 is negative 6, plus 6. Here again, they want you to think about finding the terms and then simplifying. They remind you that simplify means to write the expression in its simplest form. And if it's a numerical expression like these, simplest form means simply a single number. So in other words, find out what these equal. All right, same thing with C, same thing with D. And then the challenge is if you have a long expression like this, how can you change it? How can you add parentheses to it so that the resulting expression has the smallest possible value? So where could you put the parentheses in this expression so that you'd end up with the smallest final answer? And then is there a different way? Of course, there is a different way, but find a different way to add parentheses to this same expression so you get the largest possible value. So that is the classwork. We will have a separate video for the homework.